Passage 6 is not a conflicting viewpoint, so I'm going to go straight to the questions without reading anything. Question 34. The researchers conducting the studies chose to use a box made of a type of plastic rather than of wood to ensure that all the water from the melting ice would flow from the box into the trough. So that means they want all the water gone. The researchers most likely made that choice because the type of plastic, unlike wood, is, so we have porous and permeable, non-porous and impermeable, porous and permeable, non-porous and impermeable. Then we also have, therefore, incapable of absorbing water, incapable of absorbing water, capable of absorbing water, and capable of absorbing water. So they want the plastic because they wanted all the water gone. So we don't want it to absorb the water. So we want incapable of absorbing water, incapable of absorbing water. So we want F and G still. So H and J are both gone. So will the plastic be porous or non-porous? So porous is going to be like a sponge, it's going to be rough. So we don't want it to be porous. We want it to be non-porous and impermeable. So the answer for 34 is G. Question 35 says, suppose study 2 has been repeated except in a lab kept at -1 degrees Celsius. The total volume of runoff measured over 600 minutes in the repeated study would most likely have been, so near or at zero, because -1 degrees Celsius is below the freezing point of water. That's a true statement. -1 degrees is above the freezing point. That is incorrect, so that one's gone. Because -1 is below the freezing point, that's a correct statement. -1 is above the freezing, so D is incorrect. So now we can look to see, will it be the amount of volume of runoff? So it's runoff of, I believe it looks like it's water. Studies use water from the melting ice. So we're having melting ice. So if it's at -1 degrees, it's going to stay frozen. Therefore, you're not going to be able to have any runoff. So it won't be greater than the original. It'll be near or at zero because it's still frozen. There's no runoff, so 35 would be A. Question 36. According to the results of study 1, so I'm coming over to study 1 to the results. For which of the wind speeds did the runoff volume per 20 minutes decrease to zero from its maximum volume before 500 minutes? So coming over to study 1, the results here, we have the time, we have 500 minutes here. So we want to know which ones decreased to zero before this spot. So it is going to be the little diamond. We have little diamonds and we have little circles. So we have a diamond, we have a circle, we have a star, and we have a square. So it looks to be that the diamonds are before that and the squares are before that. Sorry, not the squares, the stars. I'm trying to see these. All right, here are the squares, which are the 1.0. Here are the stars, which are the 0.5, I believe. It's very hard. Let me zoom in on this. Okay, so we have, so the diamonds are before, the diamonds stop here. So the diamonds are 2.5. So we do not want F, which is 0 only. And we don't want H because it does not include 2.5. Then we want to find, are these the circles or the stars? It looks like the circles end before the 500, which is the 1.0. So that would be J. It's very hard to sometimes read the chart when all the symbols start looking the same. So 37, compare the results of the 2 trials in study 2. So we have 2 trials. In which trial did the volume of runoff per 20 minutes reach a greater maximum value? And in which trial did the volume of runoff per 20 decrease to 0 from the maximum value in the short amount of time? So let's focus on this. So greater maximum. We're looking at figure 2, at study 2. We want the one that has the greater maximum, which is the open circles, which is the without sand layer. So we know it's not A, and we know it's not B. So it's either C or D. Now coming over here, we want to see which one has a shorter time to 0. So shorted time to 0 is when it hits the y-axis. When it gets y-axis of 0, it's when it hits the ground. So the first one is also the open circle, which is the without sand layer. So the answer for 37 is D. 38, the volume of runoff measured at 200 meters in study 1, for the 4 wind speeds is best represented by which of the following graphs? So if we are looking at the 200 minutes, so we're going to look at the 200 minutes over here. We might need to zoom in again on this. We want to know which one is the hitting higher, it looks like, if we're looking at our answer choices. So we want to know, is it 0, 0.5, 1.0, 2.5? So we have to kind of put them in order. So zooming in. All right, so the 0 is I'm going to draw a little graph over here. The 0, 0.5, the 1, and the 2.5. So at the 200 mark, the 0 is the square, which is about midway, so about 500. Then the 0.5, which is the star, is slightly above that, just slightly above that. Then the 1, which is the circle, is about at the same spot as the star, so I'm going to put it about at the same spot. And then the 2.5 is the diamond, which is much lower than the square. So I have that relative shape. So it's going to go up, stay the same, and then go down. So this one goes down, that's not correct. This one goes up and then drastically down, that's not correct. This one goes up and then down, this one goes up and then down. So it's either H or J. So I need to see that the 2.5 is much lower than the rest of them, so that will give me the answer choice of J. (39) says, which factor was varied in study 1 but kept the same in study 2? So if we look at study 1 and then study 2. So we want varied in study 1 but kept the same in study 2. So if we look at these, study 2, I want it to be the same. I'm going to look at study 2. What is the same in study 2? So I can see time was not the same, which is not an answer choice. I can see the volume is not going to be the same because that's what's being tested. I can see that the type of materials that melted, if I'm looking at type of materials melted, I am using the same water throughout the entire thing. So D is incorrect because that doesn't vary. This stays the same for both. The depth of sand layer, so I'm going to go back to A. The depth of the sand layer, that was the same for study 1, and study 2, it did not stay the same because they changed it with and without the sand layer. So that's definitely not correct because they did change that. So we want 2 to stay the same, but they changed that for 2. So the wind speed, they had anything in here about wind speed? So study 1 was repeated. Step 1 was omitted. The wind speed. So in study 1, it says the wind speed was changed. It was varied. So that one does work for 1. But for 2, what about the wind speed for 2? This was repeated. Then the second trial of study 1 was again repeated, except that step 1 was omitted. No sand layer was placed in the box. The results to the trials figured 2 below. Okay, so this one is a potential because I can't find anything that says it did not stay the same in study 2. So C, the tilt of the box, I want to know if this one actually changed in study 1. So in study 1, it had looks like a 10-degree. The box was tilted at 10 degrees, so that actually stayed. We want it to change in study 1, but the tilt of the box stayed the same in study 1. So that one is gone. I can find a supporting evidence that makes that gone. So B is the only one that I can't find supporting evidence to cause it to say it's not the same in study 2. So B is the only one that I could potentially continue with. I can find evidence to support the crossing out of the other 3. So the last question, based on the diagram and the description of study 1, which of the following expressions would most likely be used to calculate the volume of the sand layer in the plastic box before chipped ice was placed on top? So volume of the box is length times width times height. So we want it for the sand layer. All right, so our length is going to be 120. So 120 times. Our width is going to be 60 times, and our height of the box is 60. However, it doesn't say what's the volume of the box, it says the volume of the sand layer. So I don't want the height of 60. I actually want the height of the sand, which is, looks like 30 centimeters. So I'm going to do 120 times 60 times 30. Well, it's definitely not F. That doesn't have the 120. G is 30, 60, 120. That one should be the correct answer. H is 60, 60, 60. That's definitely not right. And then J has that 60 in there. So that's the trap because that is the volume of the box. We want the sand layer. So 40 is in fact G.